Welcome back to another SuperMagnetMan video, or should I say SM Magnetics. You'll notice that I have the SM Magnetics shirt on in this particular video. I want to take a minute and explain how these two companies work. SM Magnetics is a sister company to SuperMagnetMan. SuperMagnetMan is our commercial one. We have our website. We've been selling magnets for 15 years on the web through that website, and before that on another website. We have been selling magnets for a long time. But one of the things that we noticed is many times larger companies would contact us, companies that are making products, companies that are needing special engineered solutions, research universities, and all of these. So we wanted a separate entity that we could process that, so we could handle it and meet their specific needs. This is SM Magnetics, and that's the role that it plays for us. This video is about the products that we developed for SM Magnetics. So many times when a customer may contact SuperMagnetMan, they find themselves diverted over to SM Magnetics. That's because SM Magnetics is better designed to handle these type custom engineered requests or mass volume requests that you may have. So we're going to take a look now. You see this massive magnet sitting in front of me. For many years, I had been trying to develop a magnetic field that would help me obsolesce my Gauss meter. My Gauss meter only reads up to 15,000 Gauss, 1.5 Tesla. And so what we did is we had a request from a customer to develop a magnet that would be over 2 Tesla. So we came up with this design and we had our factory make it for us, and it worked out better than we expected. This one is a giant magnet that has magnets, and we use our pyramid design and we stack the magnets up. And to show you the kind of fields that we're able to generate, now this is in a small volume. We're in about a 5 millimeter square area, and inside this area, we are getting 25,000 Gauss. We can stack these magnets up a little differently, and we can get 28,000, 29,000 Gauss, depending on how we arrange these magnets that we've stacked it up, which is incredible to be able to get 2.6, 2.7 Tesla out of a permanent magnet. It's not super cooled. This magnet is powerful enough to even magnetize neodymium magnets. We can take small disc magnets like this and just take a magnet like this, and as it gets close, it jumps into the center, and if it was unmagnetized, it will magnetize it as soon as it enters the field. We can pull it back out, and it is permanently magnetized. So this magnet is strong enough to magnetize neodymium. To demonstrate that this will magnetize neodymium material. Now, let me make a little side claim. We're not saying it's 100% saturation. We have tested it and it gets like 98, 99%, but this could vary between material types. You can choose other materials that may have a higher degree of, a higher requirement for magnetic field strength to magnetize them. But these are measuring like 15 Gauss, minus 2 Gauss. These are essentially dead magnets. They were sent to us unmagnetized accidentally, and so what we can do is we're just going to put it in there for a second. Now pull that magnet out and set it aside. Now we're going to take another one, and you'll see how quickly it flies into the field. Once it's in the field, all we have to do is pull it back out, and you will see these two magnets are now magnetized, and one of them, the Gauss level, will be, it's at 1900, 2000 Gauss, which is pretty close to what we get with this size 5 millimeter by 2 millimeter magnet standard, and 2200 Gauss on this one. So this is showing you that yes, this magnet can actually magnetize neodymium magnets. We have had other requests as people find the different things that we can do. They bring us new challenges. Can you do this? My favorite expression, I love the question, can you do this? I tell them quickly, we're electrical engineers. For us, all things are possible. Just add money and stir. So by this, what we want you to do is build the box around us. Tell us what your constraints are. When do you need it? How much should it cost? And we work to develop the solution for you. Let me take you through a couple of examples that we've had in other requests. To take a look at the C-magnet design, as we like to call it, what we've done is laid this out. So we have our pyramid magnets, we have a large magnet underneath it, and then we have iron cobalt that is carrying the magnetic field all the way around so that it comes back and gives us the highest possible field. On the surface of the regular platform, we're getting about 1.7 Tesla. But in this air gap, once we start stacking other magnets on top, depending on the configuration that we use, we can either have a large area that is giving us something like 2.1, 2.2 Tesla, or we can get a little bit smaller area and push it up to 2.5 all the way up to 2.8 Tesla. We are trying our best to get to 3 Tesla. We have a couple of other designs in the works that we think will get us over 3 Tesla. That's sort of our inside the company goal now, is to get over 3 Tesla with a permanent magnet that is not supercooled. And that will be another video. What we've got also is another design where we're looking at being able to have 2 sets of magnetic flux forcing into a smaller area. And see what this design. We are sending the designs to our magnetic engineer who is able to model this and give us back the data. We work with them very carefully to design exactly what our customers need. Now this top one is a very special design that we had. We had a customer that said, hey, well, they saw this video and saw that we were getting over 2 Tesla. And they saw a little article that I put on LinkedIn, and they said, can you make a 2 Tesla field that's 12 inches wide, and it needs to be about 4 millimeter gap. They had something, and as most of our customers, we may never know what they were using it for, but they wanted a slot that they could slide the object through and see if it would stand up to 2 Tesla fields. I don't know whether they were testing it with it or what they were doing with it, and most of the time, that's something we never know. They just tell us what their design objectives are. So now we're going to take a look at that in a little bit more detail. We want to take a look at this, and this particular magnet, we had to design an array that would get us 2 Tesla or more in a very small area, but it had to be 12 inches long. So you can see this is the general design, and there's the slot that the object would be fed through. When we looked at the magnetic field profile, you can see the very intense red field in the middle. This is where it's going over 2 Tesla. And as a matter of fact, you can see that across that profile, it is very even. From the very edge, we actually made the design about 16 inches wide with a little over 12-inch wide slot. But for the area where the slot is, the field is 2.1 Tesla pretty much all the way across, and it is very even all the way across. So we look for customers to bring us challenges that let us take magnet technology to the next level. To help you see one more of our really challenging customer requests, we had a request to produce an extremely large magnet. This needed to have a pull force over 1,000 pounds at 1/4 of an inch. So one of the designs that we came up with to do this was to take the magnets on the side and point them in, pushing the flux to a set of magnets in the middle that were pushing it straight up. You can see the lines separating it as we look at it through this viewing film. I'll let y'all get a good shot of that. The viewing film shows you the solid lines where the poles change. What this magnet does is give us an extremely powerful field all across this surface. We are measuring 4,000, 4,600, 5,000, in the middle, 5,500, 4,600, 5,300, 5,600. We have an extremely powerful field. Now keep in mind, this is encased in stainless steel. This was for an application around the ocean. It was going to be used on ships, and it needed to be protected so that it would not rust. These magnets needed to be lasting for at least 10 years. Whereas regularly, if you don't have that kind of a plating on it, you don't have stainless steel, this type magnet would just erode away in a year or two's time. This one is able to last a very long time because it's completely encased in stainless steel. We also had to laser weld it because magnetic fields this powerful, you cannot arc weld with them. These are the kind of things that we work with customers to develop. Now, one of the things to point out is we can't tell you about a lot of the products that we work with because we sign NDAs, non-disclosure agreements, with our customers so that we do not tell about most of the things that we do. These are some of the things that we have done that aren't necessarily covered by an NDA, or there have been many, many years ago that we did these. But I wanted you to see many of the things that are coming out today, we may have had a part in that. You just don't know, and we can't tell you. And if you have a product that you want to keep secret and you want us to stay as your proprietary partner, we would be delighted to work with you as well. So as you look over your applications or your product development or your research that you're trying to do at a university, contact us at SM Magnetics or SuperMagnetMan, and we'll get you to SM Magnetics so that we can help you get exactly the right magnet for your application. At SuperMagnetMan or SM Magnetics, we're always looking for customers who want to take their technology to the next level.